You know how planes are these amazing feats of engineering, right?
Mm.
Well, get this. Today, we're going to really dig deep into a part of that that's often like hidden in plain sight.
Yeah.
We're talking about the system of fluid lines and
Mm.
fittings that keeps everything running smoothly up there at 30,000 feet.
Yeah, it really is like the circulatory system of the aircraft, if you think about it.
Totally.
You've got fuel lines delivering that power to the engines, hydraulic systems controlling those crucial flight surfaces, even, those oxygen systems, that you hope you never have to think about.
Yeah. Fingers crossed. Right.
Yeah.
And it's actually pretty amazing how much goes into making sure these systems are like top-notch, totally safe, reliable. We're talking about choosing the right materials.
Mm.
Like, do you use this kind of metal or that kind? Understanding what makes a good flare on a fitting. And even how do you bend a rigid tube without, like, totally messing it up?
Yeah, and, it all starts with those materials.
Okay, so it's more than just, like, connecting point A to point B.
Oh, for sure.
It's got to be the right stuff.
You got to have the right stuff. And in an airplane, that's asking a lot.
It is. So let's break this down. We've got these two main types of lines. We've got the rigid lines and we've got the flexible lines. What's the deal there?
Okay, so imagine this. You wouldn't use a garden hose for your home's plumbing system, right?
Hopefully not.
You need something much more durable, something that can handle pressure. And that's where the rigid lines come in.
Okay.
They're typically made of metal, and it's all about strength resisting corrosion, especially in high-pressure situations like those hydraulic lines controlling the aircraft's every move.
So those are those metal tubes you see running along, like inside the structure of the aircraft.
Exactly, exactly. And those tubes, they come in all these different sizes, and those sizes are measured in a really particular way. We use fractions of an inch to describe their outside diameter.
Fractions of an inch. So we're talking like, quarter inch, half inch, that sort of thing.
Exactly, you got it. But there's another thing too. The wall thickness of the tube, that plays a huge role as well, and that's measured in thousandths of an inch. And that thickness, that tells us how much pressure the tubing can actually withstand. So the thicker that wall, the higher the pressure it can handle.
So, okay. It's like choosing between like a regular garden hose and one of those heavy duty ones,
Yeah. Mhm.
for like a pressure washer.
That's a great analogy. Exactly. Now, for situations where you need that flexibility, like those lines connecting to the engine, it vibrates like crazy during operation, that's when you'd use the flexible lines. And those are usually made of like different hoses.
Got it. So it's all about like finding that sweet spot, that balance between strength and then flexibility, right? Depending on what the job is.
100%. And when it comes to the rigid lines, one of the top choices, kind of the gold standard, is that corrosion resistant steel, CRE.
CRES.
Okay.
Got it.
Now, you might be surprised to hear that using aluminum alloy tubing instead of steel for certain parts of an aircraft, that can actually save hundreds of pounds.
Mhm.
Hundreds of pounds.
Really? Okay.
Oh, yeah. And that translates to, what does that mean? Big fuel savings, less emissions.
Oh, wow. So it's better for the environment too.
It is. It's also incredibly resistant to corrosion, making it, really popular for things like fuel lines, some hydraulic systems.
Okay, so if aluminum is lighter,
Yeah.
right, and it stands up to that corrosion, why not just use that everywhere?
Well, here's the thing. It's not quite as strong as CRES. You wouldn't want to use it for those, really high stress applications like the hydraulic lines that control the landing gear. Those need that extra muscle that CRES brings to the table.
Okay, so it's all about like matching the material to the job at hand.
You got it.
Okay, makes sense. Now, in the materials that you sent over, there was a mention of Monel. What is that?
Monel is really fascinating, actually. It's a nickel copper alloy, and it's known for its, almost supernatural resistance to corrosion. Even better than CRES in certain situations, like think saltwater or exposure to certain acids.
Wow.
It's often used in those really critical systems near the engines or in areas that are, exposed to the elements.
So CRES is like the everyday workhorse. And then Monel is like, okay, we need to call in the superhero for this one.
Yeah, that's a great way to put it. Although, you know how superheroes, they always have that weakness?
Right.
Monel can be really tough to work with. It has this tendency to harden really rapidly during machining, which makes it more difficult, more time-consuming to actually shape and form.
So it's a trade-off.
Yeah.
But it sounds like that trade-off might be worth it for that extreme corrosion resistance.
Yeah.
Okay. But before we go any further, I have to ask, how can you tell all these different types of tubing apart, especially like when they're already installed in the aircraft? It seems like it could get a little confusing, especially in those really tight spaces.
That's a great question. It's all about those color bands you see on the tubing.
Okay, so that's what those are for. I've always wondered.
Yeah, think of them like a secret code,
Ah,
but for aircraft materials, each color, each combination, it refers to a very specific alloy. And this way, technicians, they can just look at it and instantly know what they're working with.
hmm?
No need to run tests or anything like that, which is really, really important when you're doing maintenance or repairs.
So it's like this whole visual language for aircraft materials. Who knew those little bands held so much information?
I know, right?
Okay, so we've got our pipes, but we need something to hold them all together, right?
Right.
I'm talking about those connectors, the fittings. Those seem pretty darn important.
They are essential, yeah. Absolutely critical.
Okay.
Fittings, they're like the unsung heroes
Okay.
of this whole aircraft plumbing world.
Right.
And they come in all different shapes and sizes, just like with the tubing.
Uh-huh.
Selecting the right type that's really important.
Okay.
And we can basically divide those fittings into two main categories. You've got your flared fittings and your flareless.
Flared versus flareless. Okay, I'm sensing a theme here.
Yeah.
The aircraft world, they really love their options.
It's all about, having the best possible solution
Right.
for each situation, right? So each one has, kind of its own pros and cons. Let's start with the flared fittings.
Okay.
Imagine like the bell of a trumpet,
Okay.
but for tubes.
Okay.
So the end of the tube, it's actually like expanded outwards, creating this wider surface area. And then that flared end, it gets clamped down on by a nut and a sleeve to make this like really strong seal that's really good at resisting vibration.
So that's what those tools are for that I saw in the training materials,
Mhm.
to make that perfect flare.
That's exactly it. But that whole flaring process, it takes, those special tools
Huh?
and a certain level of skill to get it just right.
Right.
If you don't do it exactly right, you could end up with leaks or like a weak joint. And that's where the flareless fittings come in.
So no flaring, less room for error. So why not just always use the flareless?
Well, every rose has its thorn.
Right.
Flareless fittings aren't quite as good at handling constant vibrations and pressure changes that you just get on an aircraft,
Uh-huh.
especially compared to a really well done flared connection.
Okay.
Think about the stresses on, like an engine during takeoff.
Mhm.
Or the hydraulic lines when you're landing. Those situations, you need the toughness, the ruggedness of a flared fitting.
Okay, so we're back to that trade-off concept.
Yeah, exactly.
It sounds like both of these types, though, they both have a place.
Yeah,
Depending on, what the application is, what the vibration levels are, those kinds of
yeah,
things.
for sure.
Okay.
Choosing the right tool for the job. Right. And that goes for the materials, too. Now, you might be tempted to think, I can use any kind of metal, mix and match, it'll be fine. But there's this hidden danger in the plumbing world called dissimilar metal corrosion.
Dissimilar metal corrosion. That sounds ominous. Kind of like a villain, lurking in your plumbing system.
It really is. It's, think about what happens when you leave like a steel tool out in the rain.
Yeah, it rusts.
It rusts, exactly. That's corrosion. Now imagine that happening inside your aircraft's plumbing.
Oh, no.
Slowly, just, day after day, weakening those critical lines.
Oh, good.
Yeah, that's dissimilar metal corrosion. It's this sneaky kind of electrochemical reaction. Happens when you have these two different metals, let's say aluminum and steel, touching each other, especially if there's moisture present.
So even a little bit of condensation could cause a problem.
Over time, oh, absolutely. It's like you're basically creating this mini battery inside your plumbing system, and one of the metals is slowly kind of sacrificing itself to the other.
Wow.
And this can lead to, cracks, leaks, even total system failures.
Yikes. Okay, that's definitely not something I want happening when I'm, up in the air.
Yeah, nobody wants that. That's why it's so important to always, always use fittings and tubing made from those compatible materials. And you got to follow the manufacturer's recommendations. It might seem like this tiny little detail,
Right.
but it can make all the difference.
Big time. So it's not just about connecting the dots. It's about, really understanding the materials, how they work together, the fittings, all of that.
Exactly. Fabricating a tubing assembly for an aircraft, it's a process.
It's an art form.
It really is. Think of it like a combination of, craftsmanship, and then following those really, really, really important instructions.
Got it. So walk me through it. What are those key steps to building one of these systems?
Okay, so you start by cutting the tubing to the right length.
Okay.
Now, that seems pretty basic, right?
Yeah.
But it's super important to get this perfectly clean, square cut. so that it seals properly with the fitting.
Got it.
Any little burrs, irregularities, anything like that, those can create weak points. They can even prevent that fitting from, like, seating correctly, and then you increase the risk of leaks.
So precision is everything, right from the very get-go.
100%. And that's why the next step, deburring, this is super important too. And deburring, what that is basically removing those little metal shavings or burrs that are left behind from the cutting.
Wait, so something that small can cause an issue?
Oh, yeah. Even a tiny burr, it's like a little wrecking ball.
Really?
Yeah. It can damage those delicate components downstream. It can cause a blockage. You never know.
Wow. Okay, it's incredible how something so small can have such a big impact. So what's next after the deburring?
Then you've got bending,
Okay,
if you need to, that is.
right.
And this is where it can get a little tricky.
Yeah.
Because the goal is to make this smooth, even bend without kinking the tube or collapsing it.
I would imagine trying to bend something as, rigid as a metal tube without kinking it is a lot easier said than done.
And it takes a lot of practice.
Right.
It takes the right tools. There are hand-operated tube benders for those smaller diameter tubes. And then for the larger, more complex bends, you'd go with like a bench-mounted bender.
Okay. What about those really tight bends, though? I've seen in some of those aircraft diagrams. Those seem like they'd be, like, next level.
Oh, yeah. Those can be tricky. For those really small diameter tubes or those really tight bends, sometimes mechanics, they use this trick. They'll use, like, a tightly wound spring or even, believe it or not, just clean, dry sand. Yeah, packed inside the tube.
Really?
Yeah. And what that does is it helps support the tube wall so it doesn't collapse during that bending.
So they're using, like, everyday materials to solve these complex engineering problems. That's really cool.
It is cool. And it just goes to show that, even in a field as, high-tech as aviation, sometimes those simple solutions are the best. But we're not done yet.
Oh, no.
Once the tubing is cut, deburred, bent if you need to, the next step is installing those fittings.
Okay.
Which is a whole process in itself.
So there are even more specialized tools and techniques that go into that.
Oh, yeah.
Okay.
And getting it right. That's just as important as all those other steps.
So we've got our tubes all cut, deburred, bent if we need to, right?
Right.
Now it's time to actually, like, connect those perfectly prepped tubes with the fittings.
It's the moment of truth.
It is. What's the trick to making sure those connections are going to, hold up under pressure, no leaks? Everything's got to be perfect for flight.
Well, it's like everything else in, this world of aircraft plumbing.
Right.
It's precision, and it's following those procedures to the letter.
Okay.
With those flared fittings, you'll need that flaring tool, right?
Right.
To get that really precise flare on the end of the tube. And then you've got to use the right wrenches to tighten that nut and sleeve onto the fitting body.
Yeah.
And you've got to hit the specified torque.
The specified torque. Okay, so there's no eyeballing it. It's not just like, all right, that feels pretty tight. Let's go with that.
No. You can't just crank it down as hard as you can. You'll end up damaging the fitting, weakening the tube. And then on the flip side, if you don't tighten it enough, you guessed it, leaks.
Right.
That's why mechanics, we use something called a torque wrench.
Yeah.
And that fancy tool, it's designed to like click or give you some kind of visual indication when you've hit that magic number, that torque.
So it's like this little safety net.
Yeah.
To make sure that those connections are, not too tight, not too loose.
Exactly.
Goldilocks would approve.
Exactly. Now with your flareless fittings, it's a little bit different. You're not flaring that tube.
Right.
These fittings, they use this special thing called a ferrule.
Okay.
And that gets compressed onto the tube as you tighten that nut. And that creates the seal.
Okay.
Again, you need a specific kind of wrench for that.
Right.
And getting that correct torque. That's super important.
It seems like each type of fitting, it's like its own little world.
It is.
With its own tools, its own procedures.
It takes a lot of specialized knowledge to work on these systems, for sure.
It does. And speaking of that specialized knowledge, we've got to talk about one of the most important parts of, keeping these fluid lines, these fittings, all of it in tip-top shape.
Oh, absolutely.
And that is inspection and maintenance.
So important.
Right, because these systems, they're constantly being put through the ringer. Yeah.
Extreme temperatures, pressure changes, vibrations.
All of that. So it's not like a set it and forget it kind of deal.
Oh, no, not at all.
Okay.
Those regular inspections, they are key to catching those little issues before they become big problems.
So it's like going to the doctor for your yearly checkup.
Exactly.
A little preventative medicine goes a long way. Okay, so what are they looking for when they're doing these inspections? Are they checking for leaks, corrosion, like general wear and tear, all of the above.
You nailed it. It's all of that. And they've got all these different methods for doing it. Sometimes it's just a visual inspection, right?
Yeah.
Looking for any obvious damage, like, maybe there's a dent, a scratch, or the color's off. But sometimes they've got to bring in the big guns. Things like dye penetrant testing.
Dye penetrant testing. All right, that sounds pretty serious.
It's actually pretty cool. So they take this special dye and they put it on the surface of the fitting. And that dye, it's got a way of like working its way into even the tiniest little cracks.
Wow.
The ones that you can't even see. And then they clean it off. And they put on this developer.
Yeah.
And the developer, it reacts with any dye that's left. And it's like, boom, highlights those cracks.
So it's like giving the fittings an X-ray.
Exactly.
That's really cool. Okay, so they do all that and say they actually find a problem. What happens then?
Well, then they got to figure out the best way to handle it. Sometimes it's a super easy fix. Maybe a fitting's loose, they just tighten it up.
Right.
Or, replace a seal, no big deal. Right.
But then sometimes it's a little more involved. Maybe they have to replace a whole section of tubing.
Right, like cut out the damaged part and then put in a new piece.
Exactly. And then, of course, they got to follow all those, precise fabrication installation procedures that we talked about before.
Wow. It's amazing how much goes into every single aspect of aircraft maintenance. Even something, like fluid lines and fittings, it seems kind of basic, but clearly not.
Yeah.
Really highlights how important it is to have those skilled technicians who know this stuff inside and out.
Absolutely. I mean, it's really what keeps those planes up in the air.
That's right. Well, there you have it. Our deep dive into the world of aircraft plumbing. Who knew there was so much to it?
Right.
We talked about the materials, those fittings, how it all gets put together, how to make sure it stays in good shape. And it's really like this hidden world,
Behind the scenes.
behind the scenes, keeping those amazing flying machines soaring.
It's a critical part of it all, that's for sure. It is. So next time you're on a flight and you're looking out the window at the clouds, just take a moment to think about those hidden systems.
Yeah.
Work tirelessly behind the scenes to get you where you need to go safely.